Alright, question 7, differentiation, my favorite topic in high school math. So 7.1. 7.1. We're told to determine f prime of x from first principles if it is given that f of x is 4 minus 7x. So we are given f of x equals 4 minus 7x, and now we need to find our derivative from first principles. And first principles state that the limit as h approaches 0 of this function, f of x plus h minus f of x over h. Okay, and what we want to do for a limit is substitute the 0 into the place of the h, but if we do that now, we'll be dividing by 0, which is not allowed. Doesn't give us anything proper. It's undefined. So we first have to do some manipulation. So the limit as h approaches 0 of this function. Now, what is f of x plus h? That is when we replace the x with x plus h. So we got 4 minus 7x plus h minus, and then our initial function, which is 4 minus 7x. All of that over h. F prime of x equals, and now we need to remember to keep writing this part, the limit as h approaches 0, until we actually do the substitution, or the h's are completely gone with cancellation or something of the sort. Okay, so let's multiply out and simplify the top. So we've got 4 minus, and then 7 times x is 7x, minus 7 times h is minus 7h, minus 4, and minus times minus 7x is plus 7x. All of that over h, and we can see here that 4 minus 4 is nothing, and 7x minus 7x is also nothing. So what we're left with is f prime of x equals the limit as h approaches 0 of the following, of negative 7h over h. And then we can see the h's here can cancel, so finally we're just left with f prime of x equals negative 7, and that's it. And you can validate your answer or verify it by using the short method of differentiation if you're comfortable with that, and I think most of you will be. So that's a nice way to verify. And remember, we have to use this long method, which is the first principles, if they tell us to do that. If you just wrote the answer negative 7 with the normal differentiation or the short method, you'd probably just get 1 mark for getting the correct answer, but not for following the instructions. Okay, so that was 7.1. Now 7.2 I'm just going to do below here. 7.2, we're told to determine dy dx if y equals 4x to the power 8 plus the square root of x cubed. So I'm just going to write down y equals 4x to the power 8 plus the square root of x cubed. And now before we find dy dx, I'm going to rewrite y in a more suitable manner. So 4x to the power 8, that's perfect. But this part we're going to rewrite in exponential form instead of having a surd. We're going to say that is equal to x to the power inside over outside. 3 over 2. Great. Now once we have this in normal polynomial form, we can find dy dx. So dy dx just means we're differentiating y with respect to x. So x is our variable of interest. Okay, and now before we do that, let's do a recap of what the short method is that we're going to be using now. So the short method says that if y equals ax to the power n, then y prime equals, we take the n to the front, so it becomes n times ax to the power, and then we take 1 away from the power, subtracted by 1. So na x to the power n minus 1. And we'll apply that thinking right here. So we get 8 times 4, 32, x to the power 8 minus 1 is 7. And then we do 3 over 2 times 1, which is 3 over 2 x, and then we do 3 over 2 minus 1, which is a half. And that is fine. That's a perfect way to leave your answer. If you want to write it in surd form, you're welcome to do that as well, which would be 32x to the power 7 plus 3 over 2, and then x to the power half is just the square root of x. And both of these are 100% correct. Alright, that was 7.2. Now we get to 7.3. So 7.3, let's see what that gives us. 7.3, we're told given this equation, so let's write that down first. Y equals ax squared plus a. And then question 7.3.1, we're asked to determine dy dx. So dy over dx, or differentiating y with respect to x. So again, that means x is our variable of interest, which is the normal way to think about it. So again, we'll use this same logic. So we take the exponent multiplied in the front, so we've got 2 times a to the power x, and then 2 minus 1. Yeah, let's just write down all the steps for this one. Plus, and then a, there's no x. If there's no x, it means x to the power 0, right? Because x to the power 0 is 1. Then we can simplify this, becomes 2ax, and this becomes, if we want to do all the steps, 0 times a to the power x, and then 0 minus 1 is negative 1, which finally gives us this. And I know this is a little bit tedious, but I'm just doing all the steps to see why, if we just have a number, we can ignore that. And this would be because 0 times anything is 0, which means we just have 2ax. That's our answer. And for 7.3.2, we're asked to find dy dA. So dy dA. So the difference here is now a is our variable of interest. So we're differentiating y with respect to a, which would mean if we had a graph over here, then this would be y and this would be a. Okay? So that's why a is now our variable of interest. That is now the independent variable. Okay, so what we'll do is now in this equation we've got the coefficient of the a is now the x squared. So we take the exponent of the a, which was a 1, and multiply it by the coefficient, so 1 times x squared a, and then we've got 1 minus 1, plus we've got a, so we take this 1 here, 1 times the 1 in front, so we've got 1 times a to the power 1 minus 1. Okay, so that's just doing all the steps. So 1 times x squared is x squared, and a to the power 0 is just 1, so we don't have to write anything there. Same here, we've got 1 times, and a to the power 0 is 1. So that's our final answer. What you could have also done as an alternative way of viewing the question, let's say alternative method or view, that would be if we said let's rewrite this equation as y equals, and then factor out a as a common factor. So we'd have 1 plus x squared, or x squared plus 1 times a. Okay, and now if we do dy dx for this, so dy dA, then we'd have 1 times this, so that's x squared plus 1, and then that whole thing times a to the power 1 minus 1, because we subtract 1 from the exponent, and that'll finally give us that we've got x squared plus 1 times a to the power 0, and a to the power 0 is just 1. So there's our answer. So we see it's exactly the same. These two things are equal. Alright, that was 7.3. Now let's move on to the next page for 7.4. Okay, 7.4. 7.4, let me write that down here. 7.4. Okay, let's read the question. The curve with the equation y equals x plus 12 over x passes through the point A, which is, let me write down the equation. Y equals x plus 12 over x, and it passes through the point A, which is 2 and B. Okay, determine the equation of the line perpendicular to the tangent of the curve at point A. Right, so uh, I just went and did a graph of this function because we don't really need to know what this looks like. That's not a type of function or a graph that we've studied. Uh, on the small scale, it looks like a normal hyperbola. If you zoom out a little bit, you'll see that the asymptotes are skewed a little bit. They're not just horizontal and vertical, and that's the difference. But for now, the important thing is just to get an idea of what it looks like. So we're asked if there is a tangent at this point at A. So A is where we go with 2, right? So that's right there. So if we draw a tangent to that point, and now we need to find the equation of the line perpendicular to that tangent. So perpendicular to that tangent would be this one, which makes a 90-degree angle there. Okay, so this is the equation we want to find. So that has the form y equals mx plus c. It's a straight line. Okay, so that's our end goal. Now let's see how we get there. I would suggest the first thing we do is we find the value of b by substituting 2 into the place of x. So to find b, we'll say y, or we can actually from the beginning just say b. So b, substitute this whole point. So b equals 2 plus 12 over 2, which gives us b equals 2 plus 6, so b equals 8. Therefore A is the point 2, 8. Alright, now we have a coordinate, a full coordinate. So let's first find the tangent, the green line. So the tangent has the form y equals mx plus c. And to find the gradient, so the gradient of the tangent here is exactly the same as the gradient of this line at that point. Okay, so we need to find the gradient of the curve at the point when x equals 2. So the gradient is, let's just draw a line there. The gradient is y prime, right? So this thing, if we differentiate it, we get the gradient. So let's first, before we do y prime, let's just rewrite this equation as x plus 12x negative 1, just so we have it in this form. And now we can differentiate that, and we get, if we differentiate x, we get 1. If we differentiate this, negative 1 times 12 is negative 12. And x, we take another 1 away from the exponent, so x to the power, negative 1 minus 1 is negative 2. So let's just rewrite that as a thing without a negative exponent. To make it positive, we take it to the other side of the line. So here we have our gradient of the curve, But we want this gradient. What is the gradient when x is 2? So we'll substitute a 2 in. So y prime of, let's say, 2 equals 1 minus 12 over 2 squared. That gives us 1 minus, what? 1 minus 12 divided by 4 is 3. So that is negative 2. Negative 2. Okay. So there is our gradient. Okay. Now we need to find the gradient of the perpendicular line. So the perpendicular line, that is when let's move down a little bit. So we know to find when lines are perpendicular, what do we know about that? We know for perpendicular lines, that the two gradients multiplied together must equal negative 1. So we have one gradient, the gradient of one line, that is negative 2. So times the gradient we want equals negative 1. So the gradient we want is negative 1 divided by negative 2, which is a half. Okay. Okay. There we go. Then what we can do from here is we can say, okay, so far we know it's y equals a half x plus c, and to find the value of c we can substitute a point. But luckily we do have a point, point A. So if we substitute A, we get 8 equals a half x, and x is 2, plus c. So 8 equals 2 times a half is 1 plus c. So 8 minus 1, 7 equals c. So our final answer is y equals half x plus 7. Right. And that is our answer. So that is the equation of the line perpendicular to the tangent at the point A. Great. So if you did any of the questions in a different way, please let me know. Or if you have any questions about why we use something, some formula or some method, please ask that and we can address that. Thank you.